Today we're going to take our first look outside of the Haskell prelude by looking at another module called QuickCheck. Now QuickCheck is quite widely used in programming. First it was implemented in Haskell, it's now in Java, Python, a bunch of other languages. I think there's something like 20 odd languages that have some version of QuickCheck which has been re-implemented from Haskell into that language. Now what QuickCheck does is it takes some sort of condition, something called a property, or some people would refer to it as a proposition. You can see that here. This is the QuickCheck function. Now this proposition is essentially something that resolves in a Boolean type and checks some property of a function's behavior. Now what QuickCheck will do is it will generate random data sets to compare this property with, and it will try and falsify that condition. It will tell you whether the function passes all of these criteria or whether it doesn't. So we're going to have a look at defining a couple of these propositions today. Just some simple ones, some basic ones to get started. And this will also help you come up with your own counter cases when you're working with Haskell, things like that. Now, to use QuickCheck, you'll need this import test.QuickCheck up here. You will also have to do stack install it's capital Q here, something like that. And Stack should handle the installation for you. If you have any issues with that, let me know. I would do it myself, but I already have it installed, so it's a wee bit of a faff to uninstall it and then reinstall it for me. So, I've got two functions here. I've got factorial function, simple function that you should all be used to, and I've got myRev function. Now, what we essentially want to do is use other predefined abilities or logical conditions to say this is what should happen if I've correctly defined this function. So for example, for the factorial, this is one recursive implementation, but I know that should also be equivalent to using fold_r, or it should be equivalent to using product over a list. So let's define that condition here. So we're going to say prop factorial. Now usually these are start with the prop prefix underscore. I much prefer camel case, but the QuickCheck library uses this prop underscore thing so that you can run all of your tests at once if you wish. So we have prop x's for factorial. This is where I should define what the actual property that should hold is. So I should say factorial x's, and let's say this is equal to the product of the list 1 to n, not 5. That should be x's. I've decided to use x's for some reason. Let's make that a little bit more sensible by changing that to n. I think I'm looking ahead to the next one without realizing where I am. So this is a condition that says if the factorial has been appropriately defined, it should be equivalent to this. You could replace that product 1 to n with factorial, the multiplication, the accumulator of 1, and then the list. Either way is fine. So now we can reload, and if we go into QuickCheck and we carry out prop factorial, QuickCheck will very quickly run, and it will tell me that it's passed all of the 100 tests. Now this is quite a simple one. We could change our factorial definition and we could see that it would go wrong. So for example, if I just say, so this factorial function can handle negative cases, and QuickCheck will generate negative numbers to check. Quite often that's one of the first things it does with an integer check is just to say -1. What happens in that case? So if I say n equals 1 and I reload, that compiles fine, but what we want to do is QuickCheck, and now we can't get past the first test, and that's because it's trying to instantiate a negative number to see if they're both equivalent in that instance, but my factorial will never return on a negative number because it'll keep going and keep going and keep going until its stack overflows. So that's one property defined, and that's one test carried out. So it's quite simple so far. Now next we have myRev. Now this is a function which just reverses a list. You've seen this definition earlier on in the class, but we want to think about how we might test this. And you might think this is a little bit tricky. We could compare it to a prelude function if we wanted to, but it might not be a bad idea to just compare it with itself. So what I'm going to suggest we do is we do prop rev, and this time it should be x's. Now what I'm going to say is, if you reverse a list and then you reverse a list again, that should be what we call the identity, but that should mean that it's equal to the original list. So if I reverse something, reverse it again, that should give me the original list. So I'm going to say my rev, and I'm going to say my rev x's, not capital X's, I seem to love capital X's, should equal x's. So if I reverse it twice, should get the same thing out. So let's save that. and then we can do QuickCheck, and this should be prop ref. And I guess we pass 100 tests. So this is just a brief introduction to the QuickCheck package. We'll see a little bit more of this. One thing that I've also glossed over here is the fact that this returns the IO type. Now the IO type is a monad instance, and it's how we handle input, output in Haskell as you would expect. We'll see how to do that later on. For the moment, what we're going to do is just get used to defining these sorts of properties in Haskell. Sometimes it can involve quite a bit of brain work just to figure out what should be happening. But we'll get some experience with this as we get along. Again, the purpose of this video is just to show you how you would install it using the stack install command, and how you would define some basic properties for functions. That's everything for today. Of course, if you have any questions, please feel free to get in touch. Thanks.